Welcome to a new video on my home automation and on-thread series. And today I'm going to show you how you can convert your Blitzwolf SHP6 or SHP2 smart plugs to Tasmota. The main reason I'm doing this because these are nice power consumption monitoring smart plugs, and I want to be able to use those power consumption features in Node-RED. And Tasmota is able to support these Blitzwolf devices, and it looks like that many people have started flashing these devices and they work just fine with Tasmota. And actually there is a whole load of documentation behind it. So everything that I do is well documented in various wiki pages within Tasmota, but still it's a lot of different process that I would like to just summarize in one single video. So I will be doing this in the SHP6 and the SHP2 as well, and the Node-RED integration part of it I will cover in the follow-up video, because I think this is probably going to be a long enough video anyway. And sorry for some of the substandard videos, but I was doing most of this stuff in the evening, so the the light condition wasn't ideal. So I'm just going to probably leave the the footage as smaller versions in the corner. But as I said, most of it is documented, so you can just follow my videos as well, and you can follow the various online wiki pages on in each step of the process. And of course, everything is going to be in the video description. If you Google Tasmota and SHP6 or SHP2, you will most probably find these pages, these wiki pages on the actual Tasmota GitHub repository, which is about how you can change the firmware on these two devices. And it looks like that there are other manufacturers that are using the same physical design, probably not so much with the SHP2 but SHP6, but on the SHP2 it is also mentioned that the SHP2, it's almost the same as the HomeCube SP1 and the Tekin SP22. It's basically the same design. But let's start with SHP6 first. I think probably this is the easier one because there's not so many hardware variants of this device. So it's a really small package. So I think with this whole process you need to be really fine with tweezers and small devices and then small soldering irons, because we are going to be dealing with small physical package. That's the plug. The first thing that you need to do is you turn it upside down, and within the the French earth plug hole you have a long screwdriver, because there is a screw inside it, so you have to unscrew that. And once you unscrew it, then the transparent plastic from the other side just slides off, and that reveals the internal PCB. So here we have two things to do. First of all, you have to pop off the antenna connector. So the antenna is just like a piece of tape which is glued inside of the case. So it is going to be difficult because they're really small stuff, it's hard to reach. So I managed to put a tweezer under it and then basically just sort of like pry it off, but just make sure that you're not damaging anything on the PCB. And so once it pops off, then just bend it off out of the way. And there are two more screws inside the the two European plugs. Again, you need a long screwdriver to reach inside and unscrew that. And once you have done that, you would be able to remove the PCB, which is again is going to be difficult because it's a very a tight fit, and it also has to go around the small cable of the antenna. So just start to wiggle it gently. Of course, it's difficult to grab the whole PCB. So I had a fine tweezer. I put it into the hole of the plug, and I sort of like try to pry it off very gently. And once you have done that, then on the main side you find 5 contacts. So you see here in the picture 3.3 volts, RX, TX, and then ground, and also there is one which is called the IO0. So you need to solder wires for all 5 of these test points. And I just use some piece of wire like a jumper wire. So it's not too difficult because these solder points are away from any other components, but still you probably need a fine soldering wires and then 5 wires. And what is also mentioned in this wiki, that as somebody actually designed a 3D printed plug which can connect to all these test points on the PCB. So if you are planning to mass flash these devices, you might want to invest some time 3D printing this one. But since I was doing a one-off, obviously I didn't do any of that. And that's basically the setup of it. We would need to connect these 5 wires to our FTDI. I would say any FTDI would do. In the forum, somebody says that it has to be the CH4340 type FTDI. I have the one which has the CP1201 chip, and it was working fine. The only thing is, because it's an ESP8266, it has to be an FTDI which works on 3.3 volts, so not in 5 volts. So I have a version which has several pins, so it has a pin for 5 volts, 3 volts, RX, TX and ground. So obviously we are going to use the 3.3 volt pin, the RX, the TX and the ground. And the 5th wire, which is the IO0, that's the GPIO0, a pin of the ESP8266. And if you have flashed in ESP before, you know that if you want to flash it, you have to connect it to ground when it starts up. So that's going to be an extra step in the process where you have the FTDI, this whole device, you need to plug it in, and then at the same time also ground the IO0 connection for a short period of time when you plug it into the USB. Let's not do the the plugging in and the flashing at the moment, because probably what I would do now is just to go through the process for the SHP2 as well. And as I said, there are different variants. If you're not using the Blitzwolf, you have one of these other products. It's pretty much the same process. And my recommendation before you start with the SHP2 is that you also read this page through, because it looks like that the SHP2 has some different hardware variants, and also these other products differ to some extent. Disassembling it is rather easy because it has 4 screws on the underside. The only difficulty is that these are the type of screws where you need a triangle shaped bit. So you just need to have that. Once you have that, it's fairly easy to disassemble. And once you get the 4 screws out, you can just lift the top off. And that reveals the PCB. The problem is that the connections on the PCB are on the underside. And there are, as you can see, there are some tabs on the plastic casing on the other side, so that keeps the PCB in place. So just gently bend those tabs away, not breaking them, and then you can just lift the PCB off. You can't remove it because it's held by these thick ground wires, or the main wires. Sorry, not ground. The main wires, which are connected to the 2 live and neutral prongs of the EU plug. So you can only just lift it up or bend it sideways a little bit. I mean, I've just taken this plastic, the top, and I just twisted it 90 degrees so I can get access to these pins which are on the underside. And here again, you can see another picture here, so sort of it's like halfway open. And here there is some warning before you start soldering, because again it looks like that there are several hardware variants of these SHP2s. So I happen to have something which is version 2.3. Again, you can see the hardware variant on the main side of the PCB. It's usually written. I don't have a picture of that here. But if you flip it over, I mean, I had this set up as well. So on one side you have 3.3 volt ground, RX and TX. So just the way it is labeled here. And you also need the IO0 connection, so the GPIO0. And again, you can see the pictures here that on some variants, the IO0 is here along with the other pins. But in my version, the IO0 was on the other side. Sorry, I had version 2.4, so I had to click on this second link. Oh yeah, here you can see the hardware version, so it's printed on the main side of the PCB. So mine was 2.4, which looks like the same as 2.3, so I had to solder 4 wires like this one, and then the 5th wire was on the other side on the back of this riser board, which is labeled as IO0. So that was the 5th point that I had to solder a wire to. So in both cases, both the SHP6 and the SHP2, you have 5 wires that are coming out from the device. You have 3.3 volts, ground, RX, TX, and IO0 or GPIO0. So 3.3 volts goes obviously to 3.3 volts on your FTDI. Ground goes to ground, and then TX goes to RX and RX goes to TX. So it's the other way around. If, when it says RX here, that goes to the TX pin on the FTDI, and the TX goes to the RX. So the next tricky bit is that when you plug it into the USB, you take the 5th wire, which is connected to GP or IO0 or GPIO0, and so connect it to the ground, and then you plug it in, and then after, let's say, 2 seconds, you can let that wire go. So just make sure that that connection is tied to ground when you power the ESP up, so when you plug it into the USB. So that needs a little bit of fiddling because you have all these wires and then the pieces of the hardware lying around, and you plug it in, and then you're also holding that wire to ground. Yeah, it probably needs a few trials. If you don't do that, the flashing is not going to work. So now we have all the hardware set up. Well, probably before you plug it in, we should get ready with the software side of it. So you go back to the Tasmota wiki, and on the left menu, so you just search for Tasmota. The first hit is going to be this GitHub link, and then when you go into GitHub, you can click on wiki. You find all the documentation here. So on the left, you click on flashing. From here, we need to download 2 things. The first of all, we need this Node MCU Pi flasher. Well, you don't need this, but I think that's probably the easiest way to flash the ESP, mostly because it comes with a nice app, so you don't have to remember how to program the flasher tool. So first of all, let's download this Pi flasher. So here in the Pi flasher, download latest release, you click on latest release, and here it looks like that the latest release is version 4.0. You might have an even newer release, and here you can download the various installation programs. So either you have the 32-bit version or the 64-bit version. So that's the flasher. And in order to download the latest version of the firmware as well, you scroll up. Here it says flashing, and it says precompiled Tasmota firmware binary. You click that, and then it takes you to this page where you can click on this link here which says GitHub, and then it takes you to the list of releases. So at the moment, the latest release is 6.6.0, so I want that. And then here I just scroll down, and we need the sonoff.bin. So not the basic. I mean, of course, if you want a localized version, then you can pick the actual language, but I'm just going to pick the English one. So that's the sonoff.bin. So that's the 2 things that we need to download. And I could have mentioned this previously, but if you read through the firmware flashing instruction, there are actually other ways how to flash the Tuya devices, because both these Blitzwolf devices are supported by Tuya, and but for me that's a more complicated process. I think with minimal tools and a lot of handiwork, you can do it probably easier than how you can use the Tuya OTA functionality to update the firmware to Tasmota. But that's also possible, especially if you need to do hundreds of these. Then maybe it could be easier to invest the time to understand how this works. So I have the 2 files downloaded into a different folder. So that's the Pi flasher and the sonoff.bin. So I click on the Pi flasher. And this is the point where you should be connecting your FTDI and your device to your computer, either before starting the program or just now. So now we have the Pi flasher program running. If you have connected your FTDI, you should be able to select it from the serial port list and now, or if you just connecting it, then once you connect it, just click on the refresh button so it finds the serial port. So the next thing is that you find the sonoff.bin. And the last thing that you have to do is this flash mode. You have to set it to dual output. And also the erase flash, you select it to yes, wipe all data. So you select the serial port, sonoff.bin, you leave the baud rate as 115200, the flash mode is dout and erase flash. And after this, you just click on flash node MCU. And if everything goes right in the messages, you should see that the program updates the flash in the device. It takes about like probably half a minute, not more. So you see the the percentages going up, and at the end you get a success message and a sentence saying that you need to just unplug and plug the device back so it boots again into the new firmware. And that's it. If you have any issues at point, you might have done two things incorrectly. You have swapped the RX and the TX connections. So as I said, the RX on one should connect to the TX on the other, and vice versa. Or you might not have connected the GPIO0 or the IO0 connection to ground when you plugged it in. If that happens, just unplug it and do it again, start again, and then it should work. And once the flashing is done, the best thing that you can do is you can reassemble the device and test it that way. I mean, you can test the device while it is connected to the FTDI because that would power the ESP. And in the SHP2, I think that's absolutely doable because then the antenna is within the PCB. But if you want to test the SHP6, just make sure that you connect that small antenna connector back to the PCB, because otherwise, it doesn't have antenna, so it won't be able to pick up the Wi-Fi signal or create the, well, it would definitely create the access point, but without the antenna, you won't be able to connect to it. With the flashing done and the units reassembled, it's time to configure the Tasmota. So all you need to do is just to plug in the devices to a wall socket and then head to your computer or laptop or tablet or something. And then you should notice that there is a new Sonoff network created. I mean, one for each device that you have flashed to Tasmota. And they are going to be called Sonoff hyphen and some sort of number. And they are going to be open networks. So these are the access points that are created by the device. So you just select that access point. And again, based on your configuration, whether your device can deal with the captive portals, your Internet Explorer or your Chrome browser is going to pop up and it's going to load the configuration screen for the Tasmota initial configuration screen. If it doesn't happen, just open your internet browser and type 192.168.4.1. And then you will be presented with configuration screen. And the only thing you need to do here is you provide your Wi-Fi user ID, the Wi-Fi SSID and the Wi-Fi password. And also in the name, well, instead of the the default value, I just change it to Blitzwolf SHP2 or Blitzwolf SHP6. So it's easier for me to find the device later on. And then you hit save. And then you get a message that your device is now trying to connect to your Wi-Fi network. So the next step is you need to figure out what is the IP address this device received. So again, then you have a couple of options. You can go to your router configuration screen. You can look at the DHCP list and DHCP clients, and you can try to figure out what is the new device that got connected. Or I'm using a mobile app which is called the Fing, F-I-N-G, which again can scan your Wi-Fi network and it will find all the devices. And once you have the IP, you just type it into your internet browser and then you will be presented with the Tasmota screen. So I have one for the SHP2 and also one for the SHP6. These devices are already configured, so it's not going to look exactly the same for you. So the first thing that we need to do is you need to go into configuration and go to configure module. Tasmota has a pre-configured module type for the Blitzwolf SHP. It's called Blitzwolf SHP in 45 in brackets. And then you would think that, okay, this is what you need to set for both of the devices because they are SHP devices, SHP2 and 6. Well, it's not that easy as that. Because it looks like that my Blitzwolf SHP6, so this is the small round one, works with the Blitzwolf SHP module. So you just select that and then you save, and then the screen refreshes and you will be back in the main menu. And once you are back in the main menu, you will immediately see the power consumption data. So you see voltage and current, and you know the energy, total energy yesterday, energy today. Obviously they are all going to be zero, but once you start toggling the unit, and if you have anything connected, well, you should see the the amount of power which is drawn. Obviously the voltage is going to be there even when it's turned on or turned off, and also your the energy will start counting up. And I tried to do the same with the SHP2. So I selected configuration, and I selected module, and I selected SHP, and then it didn't work. So the power consumption measurement wasn't working, the button wasn't working, I couldn't turn it on. So after with a little bit of looking around and then Googling, it turns out that the hardware version 2.4 from Blitzwolf, which I have, doesn't work with the SHP configuration. So, you know, there is a long discussion here, but then one of the last comment was, well, actually the last comment is for me, is that you have to select the Go Sound SP1 version 23, which is configuration 55. At least this is how it's called in my version of Tasmota. And that seemed to work. So again, if I go out, as you can see, I have voltage measurement, I have power measurement, and it works. And actually this unit is connected to the charger of this laptop. So if I turn it off, you see that I'm on battery. And if I turn it on, you can see that I'm plugged in again. And it seems to be drawing, well, 24 watts at the moment. So with this done, we have done the basic configuration, but that's only the basic configuration. So let's see what else we need to do. You head back to configuration, and we have configured the module, we have configured the Wi-Fi initially, so we don't have to do anything like that. Next thing I would definitely do is configure the MQTT. Because I'm going to be using this with Node-RED, and my communication with Node-RED is going to be MQTT, that's the only thing I'm going to configure here. So you configure your host, you specify the client, user ID and the password, and also I specify the topic here. So I just put SHP6, which means that once I start receiving telemetry data, it would come through as topic tele/SHP6/ something. And if I want to send out comments to this unit, then it will be CMND/SHP6/. And I have done exactly the same with the other one. So if I go to configuration and MQTT, you see the, well, okay, I didn't put the full client here, only SHP2, but the rest is the same. The only difference is the topic. So one is going to send the topics in with SHP6 and the other one with SHP2. So that's the configuration for the MQTT. I'm not using Dolomites, I'm not using the timer functionality. In the logging, this is purely up to you. The default telemetry period is 300 seconds. So every 5 minutes, Tasmota is going to send a message like, yeah, what is the network you are connected to, what's the uptime, the signal strength, and some of the other details. I'd like it to be a little bit more frequent, so I changed it to 60, but that's not really important. I mean, other than that, the device is going to be working fine. Configure other. I just specified a friendly name, and again, I don't think it's absolutely, you know, necessary here. And go back to configuration, and yeah, and that's pretty much it. I haven't configured anything in a template. So it's basically MQTT, well, obviously the module MQTT. If you want to change something on the logging, you can do that, but that's pretty much it. Next thing is that we need to do is we need to go back to the main menu, and you want to select console. And here you're going to see all the different messages that are coming back and forth between, let's say, this unit and the MQTT server. And as you can see here, I do have a lot of stuff. You're not going to have so much stuff in the beginning, but we are going to set some defaults right in the beginning. So the first thing is PowerOnState On. Because I will be using these smart plugs mostly to monitor devices, I want to make sure that they are always on. And if let's say the power goes out, I want to make sure that once the power comes back, they switch on. And you can do that by specifying the power on state. So I just set it to what just happened. So I set it to, oh, of course, sorry. So power on state on, press enter. So you can see that now it sets the power on state to 1, which is it's on. The next one is to set the correct time zone. Once you see the messages going about, you probably notice that your time will be off. I mean, unless you live in the UK or in Portugal, because I think default time zone is GMT. So because I'm living in CET, I have to set the time zone to, I don't know, maybe this is because we are in summertime. So again, once you do that, and then you will start noticing that your timestamp for your messages matches the system time zone. So the unit goes to the NTP server to get the current time, but obviously it needs to know the time zone. So that's what you do, setting the time zone. You do have a few different options how you measure power consumption and power usage. And it is really up to you to decide how you're going to use the device and what is the best option for you. So first of all, I mentioned about this telemetry period. So whenever this telemetry period is reached, then you are, besides getting a message about your Wi-Fi status and uptime and everything, you're also going to get a telemetry message on your sensor. So you will get one message about, which is pretty much what you see on the main screen. So what is your voltage, the current, the power, and all these details. So let's say every minute or every 5 minutes, you will get an update. But if you want more frequent than that, or if you want to set up your own rules, then you do have a couple of options. And if you look at the different commands in Tasmota, again, you just head back to the wiki. On the left, you select commands, and in the section power monitoring, you can see all the different options that you have. The one thing I would probably highlight, I mean, you can read through all these options here, is the power high and the power low. So you can set Tasmota to continuously monitor the power consumption, and if it reaches a certain power as a high or a low, it would send you an MQTT message. So that means that if you are only interested about some peaks, then you can use the power high, power low, and then you will get a message once those thresholds are reached. And again, the way you do that is you are back in the in the module, and then you say power low 30, or power high 150. So that would be 1500 watts. So that's one option. The other option is, which is also related to rules. Again, if you head to the wiki and then you click on rules, where are my rules? Rules. And then within rules, you go to the rule cookbook. And here there is something about adjusting power delta according to the power values. What this power delta parameter does, the unit will still continuously monitor the power consumption of the device that is connected, but then only send a MQTT message if the power consumption changes by a certain percentage. So for example, power delta 10 says that if your power consumption changes by 10% from the previous value, it's going to send an MQTT message. So again, it's a good idea to set this up if you are only interested in the changes of the power consumption. If it stays constant, then you don't care about it, so you don't want an update. If your unit is drawing a lot of power, let's say 1000 watts, then setting the power delta to 10% is probably a good setup, because then if the power consumption varies by 100 watts, then you get a message. But if you have a unit which has a really low power, let's say 5 watts, then probably you have to want to set the power settings to, let's say 50%, 60 or 70%, because again, changes in 0.1 watt is probably not significant enough for you to send an MQTT message. So Tasmota created this example rule, which basically says that based on what the actual power consumption is, it always sets the power delta. So it makes it higher for lower power settings and makes it lower for higher power settings. So, you know, you are not getting too many messages and not getting too few messages either. And you can read the whole thing about it. So you can apply this rule. And again, the way you apply this rule is you take the first line here, you copy it to the console, press enter, and then, where's the cookbook? You take the next line, which is the rule, again, copy these 4 lines there, and then first you do rule 1, which is activating rule 1, and that's rule 1, and then this whole logic is going to be activated. So you can use that as well. The third option, what I'm using, it's what is in this text file, is to set up a rule. Well, set up a timer and set up a rule, and the timer is going to execute every 2 seconds, and then basically every 2 seconds I tell Tasmota to send me a power consumption update. And again, the way you do this is you first copy these 3 lines, you put it onto the console, and then you press enter, and then you take the next line. So this sets up the rule. So basically it says that when the device boots up, it sets the timer to 2-second delay. So this is it says timer 1 to 2-second delay. And then once the timer 1 triggers, then it should send out a status 8. So the status 8 is these messages that you see here. So stat/SHP6. So again, SHP6 comes from the MQTT configuration, and status 8, and as you can see, the status 8 contains the the time of the status, and then it contains an energy object which shows you total, yesterday, today, and then you have all the power factor, voltage, current, and all the settings that you see on the main screen. So that is being sent when the timer triggers, and then I just restart the timer. And then with rule 1 space 1, I activate rule 1, and if it didn't happen already, with rule timer 1 space 2, I activate the timer. I do the initial activation. So with these 3 commands that you put into the console, you will essentially do this, what you see on the screen, and as you can see, every 2 seconds I'm getting the status 8, and I can see it in the console, but as you can see, this is MQTT, so that's definitely goes into the MQTT, but I'm not going to go into Node-RED. I'm going to save it for a second video, but that's the setup part of it, which you have to do in Tasmota. So again, you can decide which method to use. If you want this 2-second update, you just copy these lines into the console, and I'm just going to leave this in the video description so you don't have to type it from here. And if for any reason you want a less frequent update, let's say every 5 seconds, then you need to change these 2s to 5. So the 2 here, the 2 here, and the 2 here. So any number that you want, which is going to be in seconds. I would probably say 2 is the minimum, because even if I go to the main screen here, I see these values being updated every sort of like 2-3 seconds. So I would probably not push that any further. When I said this was the last step in the setup process, that actually is not true. I mean, there are a few things that you should, look at and also consider. Going back to the not to the cookbook, but to the commands, you can see that there are a few other things here which I haven't modified. So for example, you can specify how many digits the power is going to be measured. You can do this for the voltage and the amps and the power as well. So you can see that, for example, the volts is just even numbers, the same as for the power, and the current comes in 3 digits. So you can make these changes. I don't know how accurate these devices are. Probably they are not the best devices. So these are the default values. I don't think it makes a lot of sense to get decimal places in the voltage and the power, because the accuracy is probably not that good anyway. The other thing is, which you might have spotted, is that I have these two devices, and if I flick between the two, let me go back to the main menu on the SHP6. So the SHP6 is showing 227, 228 volts. The SHP2 is showing 234 volts. Even though they are not plugged into the same socket, they are just different parts of the house, and they could be on different phases as well. I'm not totally sure, but I will still assume that these voltages have to be really close to each other. And that's the other thing which you also have to consider. You go back to the wiki, well, you do everything in the wiki, and in the menu you scroll down and there is an option which says power monitoring calibration. So I'm not going to go through this because, well, honestly, I haven't done this either. But there is a functionality in Tasmota to calibrate the power consumption monitoring of all these devices. And the whole process is explained here, which is not really complicated. The only thing you need is a regular old incandescent light bulb, preferably at least 60 watts. So that's going to be your, the test device. And of course you would need another calibrated device to test against. So maybe if you have a multimeter, or you have some sort of power consumption, gadget, which you would trust more than these Blitzwolf devices, because those will not be calibrated either. But the whole thing is that use this other device to measure the power consumption and the voltage and the amps. And there are these commands that you can give to Tasmota to set the power, to set the voltage to the value that it should be displayed. So let's talk about voltage. You take your multimeter, you measure what is the voltage in your plug, and then you come to you come to Tasmota, you go back to the console, and then you say voltage set, and then whatever number that you have measured. So this is how you set the voltage. And again, so it is mentioned here. Okay, verify the voltage with the multimeter and adjust the voltage if needed. Again, make sure that you put equal volts in. And you can do it with the same with the power. And once you have done that, then your devices should be calibrated, and if they are, let's say, plugged into the same extension lead, then at least they should be measuring the same voltage, and not like in my case where they are about, whatever, 6-7 volts out, something like that. And with this, we've reached the end of the Tasmota setup of these Blitzwolf devices. Looking at the counter on my recording device, this video is probably well in excess of half an hour, probably even 45 minutes. So I think I should really stop talking here. Go and try to replicate this process, flash your devices. It took me a couple of tries. I made some errors in the process. This is why I thought it's important to make this video. So hopefully you will make less mistakes, and it's going to be much less effort for you to get to this stage where I'm at the moment. And now what I'm going to do is I'm going to head over to Node-RED, and I'm going to work on some cool flows, how you can use these power measurement data to visualize and understand your devices, and of course set up some fancy automations to make your life easier. Thanks for watching, and hopefully see you in the next video.